So this is the Pinebox, our smart industrial IoT gateway. First I connect the Ethernet to the back of the device. Then I connect the power connection. The blinking LED shows that the system is powering up, so I can now connect the sensor for our demo to port 1. I am using the Autosen AI401 for this demo, but it will work with any other IO-Link sensor as well. Just put the sensor like this, and you see the device is still starting with the blinking system LED. The Pinebox is now ready. I can go to the browser, and because the Pinebox is an DHCP network, I can access it by providing the device's name from the back of the device. You see here the Pinebox's web interface. I select port 1 and switch on the power of this port. You see it's blinking red, which means we did not provide the IODD file yet. I can download the IODD file by just clicking the link. It leads us to the IODD Finder webpage, where I download the IODD file which describes the sensor. Now we need to select the file and upload it to the Pinebox. After uploading, the picture of the sensor is coming up. I need to provide power again, and you see the port LED turns green. Now I can check the process data that is coming from the sensor. PDV1 is the distance value. I can also check the function by reading some of the parameters. Now, to include the process data in Node-RED, I need to copy the created node description and then go to the Node-RED programming environment to configure the Node-RED flows. Select an empty tab and import the content from the clipboard. This creates the nodes specific for the connected device. To execute the node, a trigger node is required. I use this inject node with a timestamp, and I want to run this on startup and then twice a second. I am done with the inject node. Now I can add a gauge for the distance that is read from the sensor. I put this gauge next to the process data nodes. As you remember, PDV1 is the output value, which is available at this interface. For the gauge, I need to configure a new dashboard. So I add here the new tab. I put this tab on the top, and then in the tab I add a new group. So I can put the gauge on the newly created dashboard group. For the maximum value I will set 8000. This is what we have seen in the PDV1 information in the web interface. Connect the node with the gauge, and we are good to test the dashboard. Hit deploy, and we can go to the dashboard where you can see the gauge. If I add a metal object like this nut here, the value goes down. Now we can add the connection to the MQTT broker. Search for the MQTT nodes and select the MQTT out node. Connect it in the same way as the gauge. Now I need to configure this node and add a new broker connection. For this demo I use the Mosquito test broker. You can find the credentials on the Mosquito website. I use the port 1884, which needs user and password. Let's jump back to the Node-RED editor, where I need to change the port. Then I provide the access data. The username is RW and the password is read-write. As topic for my message, I use pintech-test to be able to filter the message in the broker later. Done. I can now deploy the Node-RED program. The indicator shows that the node connects to the broker. We now will use the tool MQTT Explorer to check the transfer of the data to the MQTT broker. We use the same credentials like we used before. I hit connect. Now I filter for the message pintech-test. And you see here that it comes in every 0.5 seconds. It still has a little bit of lag and jitter, but this is due to the test server. I go to the Node-RED dashboard and just move it a little, so we can see the MQTT Explorer and the dashboard at the same time. If I change the distance of my object, you see the change in both the MQTT messages and the dashboard. And that's how you get from a blank Pinebox to sensor data on dashboard and MQTT in well under 5 minutes.